Hi guys, my name is Patrick, but you can call me 26. And what we're going to do today is we are going to talk about the simplest or fastest way to measure the performance of SwiftData operations, right? So we have already looked at how you can measure operations with instruments. We have also looked at how you can use SQL debugging to measure the length of time of operations in SwiftData. Now I'm going to show you what is undoubtedly the fastest and simplest way to do it, right? Using the continuous clock. So let's get into it. Before we get to today's business, you could have a look at my course. That is the e-commerce full stack application. And what we build is iStore. And iStore, we build the front end and the back end. And iStore does use SwiftData. We use SwiftData in persisting our cart. So whenever you close the app, we save the contents of what you want to get into a cart. And in this cart, which also has a map, you can pick the location like so and do that. And this is persisted using SwiftData. And also among our carts, we have favorites, right? So we have our favorites here, and you could save the favorites, and the favorites are products that you like that you would want to maybe go back and later on buy. And this also uses SwiftData to save our particular favorites, right? So we do that. And also on top of it, we figure out how we can work with the observable macro when you're dealing with SwiftData. So all these are projects that we actually implement in this application. If you'd like to see the complete project, have a look at the link in the description. If you you're going to see the 26-hour project in its entirety plus the source code. If you would like to see the first 12 hours of the project, they're available on my page on this channel, right? So have a look at that. Now let's get to the business about the continuous clock. Now the continuous clock is a feature that came in iOS 16, and what it does is basically you give it a trailing block, right? A trailing closure. And in the closure, it measures the time of whatever happens in that particular closure, right? So you just take a trailing closure, and whatever you put inside the code, you can get the time from that, right? You can assign the time, and then afterwards, just get the time and convert it into seconds, right? If you are in an asynchronous function, you might need to await the conclusion of the time measurement, right? So how we have done it in this, and the code is going to be available on GitHub. How we have done it here is, this is a previous this is a previous app that we measured using the other two methods. And what it does is it basically makes, when you press a button, it creates randomly the names of 100,000 footballers, right? So we make 100,000 footballers and save them to SwiftData, right? And we also have a button that can delete 100,000 footballers, right? So we have a button that can delete 100,000 footballers, and we also have a button that can update, right? So every footballer will be assigned a team, right? So what we can also do is we can actually update the particular team. So the name will remain the same. The random generator for the name will remain the same, but the random generator for the team will be slightly different, right? So you will see the team change, right? And then all through this time, we'll have a sort of some text that tells you the time that the last operation is going to take. That is covered over here, right? So that is over here. You can see this, right? That's how we measure the last operation. If there's no operation, you put it at 0. And then of course there's a time, and then you're going to interpolate the time, right? And just because duration does not allow seconds, we have an extension for duration to make sure that you can get seconds in it, right? And then the 3 functionalities, right? So that's basically it. That is the entire app, and that is the logic of it, right? So what we could do is let's run it, right? And you will notice what we do here with the deletion, we actually delete the entire, just all of them in a go, right? So this is a lot faster way of deleting as compared to looping through and deleting them one by one, right? So I thought I wanted to measure the time. I was actually measuring how fast it is to delete them one by one, like in this case, where the way we are updating, right? Each single one, or deleting them en masse, right? So you can see the difference. I was measuring just for my own personal edification, right? So let's get to it. Let's see the code, right? So if you run this, what this looks like is we do not have our footballers, right? So we do not have them, and we can just hit the plus one, which is in the principal area, and this will create 100,000, and then we'll get the time that it has taken to create them, right? So let's hit that button, and it's going to take a while because it's 100,000 footballers, right? If it was 1,000, it would probably take 0 point something seconds, right? So to create 100,000 footballers, it takes 5.231 seconds, and even then you see that it's still grayed out, right? And remember, the list is optimized. The list is basically a UI table view underneath, right? So the list is a UI table view underneath and is a bit optimized for speed, right? So even then, and it doesn't load everything, stuff is lazy loaded, right? So even then you see that when you're creating the users, that the icon here is grayed out even after all of them have been created, because it's taking a bit of time from when they're created to them being shown on the screen, right? I think we already went over something like that in the previous video, right? So the creation takes 5.231 seconds, and if we hit deletion, the deletion will be very fast. And the reason the deletion is very fast is because, like I said, what we're doing is we are deleting every single, like we're deleting them en masse, right? We just check that if it's not empty, we delete them, right? So that's how we do it, right? Another way we could do, and that takes 0.207 seconds, right? I could show you how we could delete them by looping through every single one and then deleting them, and then we can compare the times, right? How we could do this is we could just come here, comment this out, like so, and then paste this, right? So for every footballer and footballers, delete them. And then for good measure, what we could do is we could just come here and we say try like so, model context.save, like so, right? We just take the autocomplete, right? Get rid of the space there, and that's going to be different, right? So let's create them. Last time it was 0.207 seconds. Let's see the improvement that we get in deletion of the footballers, right? So let's create them. Let's see how long that takes. And if you print what is happening to the console, it will take a very, very long time, right? So it'll take like a long time to do it, right? So last operation took 5.289 seconds, right? That's how long it took to create them. Let's delete them. Last time it was 0.27. Let's do it one by one, right? So that's going to be less than this time, of course. It's going to take 3.728, right? So if you're deleting stuff en masse, right, you're not leaving anything in a particular entity, right? You're deleting everything from that particular entity. Just go with the delete and then the model, right? That will get rid of everything, and it will be like several hundred times faster, I'm guessing, right? 0.2 and 3.728. What percent is that, right? It's going to be really, really fast, right? So that's one way you could do it, right? And then the slowest thing to do is going to be update, right? Update is going to take the most amount of time, right? So this is 5.146. Let's update. So right, in this case, you have Stephen Davies of Central City Athletic. If we write this, if we hit this, this is going to be the update button. Now we're going to get, it's going to be slightly longer, right? 5.587, right? So it was 5.1, but update says 5.587, right? So that is one way you could use continuous clock, and this, in my opinion, is the fastest way, the least amount of code, because it doesn't require you. The other way requires you to open the instruments app, right, which might be intimidating for users, right? It might also that might be intimidating for users. Another way would be to use the SQL debugger, which might be intimidating and is actually slow, because printing out every single, like if you're going to print out everything that happens in the in your particular, in the SQLite, right, in the SQLite default file, right? So if you print out everything, that's going to take a bit of time to do, right? And it can be very verbose, right? But this is very short, very easy to use, and it was introduced fairly recently with iOS 16, and it's all you need is just a closure, right? So that's that. Thank you for watching. Subscribe to the channel, and I will see you in the next video. Good day.